webinar, Smart Modules, a Winning IoT Device Development Strategy. I'm Amanda Flink, the head of global events here at Telit Cinterion, and I will be moderating our event today. Let's quickly get to know our speaker. To explain this topic today, I am pleased to be joined by Fabrizio Mulis, Product Manager, Smart Modules at Telit Cinterion. Hi there, Fabrizio.
Thank you, Amanda. Nice to be here.
Thank you. Now, just before I hand it over to start our presentation here, I would just like to remind our audience that you can check out the resources section here for some additional information on our topic today. There you can find the slide deck and some other resources to download. And with that, let's go ahead and get started.
Okay, thank you, Amanda. I will start. Okay, so hello, everyone. As Amanda said, I'm Fabrizio Mulas, a product manager at the Telit Cinterion of the Smart Module portfolio. In this webinar, I'm going to discuss the main approaches you can have when you want to design a new IoT product. That basically are the chip-down approach, the module approach, and the new one, the so-called smart module approach. I will focus on their main benefits, on the main challenges of each approach. And in particular, I will show you the differences in terms of time to market, NRE cost, risk profiles that are quite important, and so on. So let's start. You know that markets are more competitive every day. When you need to design a new IoT product or you need to upgrade your existing one, the approach that you choose can lead your project to success or to fail. So it's a quite important decision. It's not an easy decision. It's not easy from a technical point of view, but also there are other issues because it's not only an engineering decision. In fact, there are several elements, several aspects that have to be taken into account. Let's analyze the main ones. For example, when considering the time to market, that's quite important. Different approaches have different time to market that could be quite different. You know that having a shorter time to market can give you the first mover advantage that can bring your project to succeed in the market. Also, you know that being late in the market, yes, can cause you a loss in income by being late in the market, of course. Also, you have to consider, for example, the fixed cost that can really impact your final cost of your product. You have to take into consideration R&D costs, but also certification costs, and also the risk in failure. For example, it's quite common to fail the first iteration of certification. So you have to reapply it several times, raising the cost. Speaking about just risks, there are several points where your design can fail. You can have failures in R&D activities. You can have failure in certifications activity, as I already said. But also you can fail in your sales forecast that are quite important in choosing the right design strategy, as I'm going to show you in the next slide. Also, you have to take into consideration the internal pressures that you have from different business units. For example, it happens, I hear this thing quite often. From a technical point of view, for example, you don't need a 5G connection, but your marketing department, business unit, is pushing you to choose a 5G connection just for marketing purposes that are quite important to be considered, of course. So let's go on, and finally, let's analyze these design strategies. The first decision to make is make or buy. Make means building your end product piece by piece. This is the most difficult approach you can take, and also that one with the longest time to market. This is because you have to build everything from scratch, piece by piece. You have to deal with every aspect of the design, with the modem, the radio frequencies, the power management, and so on. On the other side, you can decide to buy a module that is already built, tested, and already certified. It embeds, of course, the connectivity, the radio frequency circuit, the power management, and so on. So it's easier to design. In certain cases, there is also the possibility to leverage an application CPU, application processor, to run your applications. Lately, smart modules have entered the IoT market. They are, let's say, quite new in the IoT field. You can think about the smart module as a kind of module with steroids, in the sense that basically it's a module, so it brings all the advantages, the benefits of a module. It means it's already built, tested, already certified, and so on. But with respect to let's say, a simple module, it brings much more advantages. For example, they have a much powerful application processor, maybe with several CPUs at high frequencies. It has a GPU, a DSP. They can also have a specific hardware, for example, a neural processing unit. Usually they have a bigger memory, like a bigger flash, a bigger RAM, with respect to just module. And in particular, they integrate many connectivity options, cellular, Wi-Fi, and Bluetooth. Also, there is inside integrated a positioning system, so a GNSS system. And finally, but not less important, they run an high-level operating system, such as Android or Linux. This is quite important as we are going to see in the next slide. So, as I already said in the previous slide, a smart module is an highly integrated module that combines processing power, connectivity, positioning, memories, and so on. But it's not only that. As I already said, they run an high-level operating system that supports out of the box many peripherals and many multimedia devices, like, for example, audio and video recording and playback. They support multiple cameras. They support high-resolution touch display, and so on. So it's quite easy to design. They already support many peripherals out of the box, and all these things shorten your time to market, your design activities. So, in short, let's see the main advantage of a smart module. As I already said, it's easier to implement a new device because they integrate many peripherals and they already support that peripheral. You don't have to deal with low-level details, with peripheral detail, you don't have to configure the peripherals because they are already supported by the operating system. They have many connectivity options that are all integrated, Wi-Fi, Bluetooth, cellular. So it's quite important I want to note that leveraging a smart module, you focus more on building software applications rather than in low-level hardware details. Usually, this is because of the high abstraction layer provided by the operating system. So you leverage the APIs of this operating system rather than working on low-level details. Also, it's important to note that it's easier to upgrade your product because you don't have to deal with IT command level details with the drivers. It's all supported by the operating system. And when you want to upgrade your existing product, you have just to switch your the existing smart module with a newer version, and you don't have to change your software application, or at least you have just to do some, let's say, small changes, some easy small changes. In this slide, now that I introduced the smart module with its main characteristics, its main features, main benefits, I want to focus more, I want to go in more details about its benefits. I already said that the time to market is shorter. This is due to its high integration and to the support of the of an high-level operating system. Also, they have less risks in using smart module because, as I've already said, you are leveraging a ready-to-use, tested, certified component. So it means less failures, less delays, and also less suppliers to deal with. This is quite important also, and it's an important aspect to consider. You have less NRE costs because you have a simplified design, less engineering resources to design your final product. All these reduced complexities, reduced risk, and so on, reduce in general the NRE cost. This is also an important aspect to be considered. In next slide, I am going to show you more details about this. In particular, I will show you some numbers to better understand the differences in costs, time to market, and so on. Furthermore, you have a less PCB surface area. This is due thanks to its integration. Less TCO, total cost of ownership, because you have to deal with only one SKU, only one vendor. So you don't have to manage to deal with external components like CPU, memory, power management unit, and so on, because they are all already integrated into the smart module. Finally, you have less BOM cost. This is because all components are integrated, and usually they are in this way. They are cheaper than buying separated ones, as you would do in a chip-down approach. So now, now that I showed you the main benefits, and I said that the smart module have less time to market, less fixed cost. I want to give you some numbers, but of course, consider that the numbers that I'm showing here are, you have to consider this number just as order of magnitude, because of course it's not possible to generalize all IoT devices design that are possible in the world. So generally speaking, I can say that in a chip-down approach, your total fixed cost could reach some million, that can reach also up to 3 million and more, while a module approach could be in general of one order of magnitude less. Speaking about the time to market, a chip-down approach could take up to 3 years, while a module approach could be more or less, could take more or less half of the time. With smart module, this number could be even less, so a shortened time to market, a smaller cost. Now that I want to discuss how to choose the right approach. So when, what are the elements you have to take into consideration to decide what approach to take? Of course, you already know the differences in time to market and in costs and so on, but there are other elements to be considered to choose the right approach. Here I'm showing you a point of view, so some elements you have to consider. I said before that a smart module have a cheaper BOM, and this is true when you want, because the components are already integrated and are cheaper than buying the separated ones. But this is true when you need all the features that a smart module offer. If you need, for example, less RAM, less flash, you don't need the Wi-Fi, you don't need the Bluetooth, and so on. Using a chip-down approach, you can optimize this cost, and you can have a cheaper BOM. In this case, of course, in a chip-down approach, you have a much higher fixed cost. So at the end, you will have a break-even point above which it will be more convenient to have a chip-down approach. So this element you have to consider. But please note that in order to calculate this break-even point, you have to rely on your sales forecast. So you have be sure that your forecast will be met. Otherwise, you will end up choosing, for example, a chip-down approach, but you will end up having costs that are much higher than the module approach or smart module approach. They are the same in this slide. Here in this slide, I want to show you another point of view for choosing the right design strategies. Here in the y-axis, in the left, we have the complexity, the fixed cost. In the y-axis, in the right, we have the time to market. And in the x-axis, we have the number of devices sold. As you can see here, similar to what I already showed you in the previous slide, the chip-down approach could be the best choice when you are going to sell a high number of devices. So your sales forecasts are really important in choosing the right approach. Of course, the time to market will be much longer and also the fixed cost. Finally, here I want to give you still another perspective. Here in the x-axis, we have in the right the shorter time to market and the lowest fixed cost. In the left part, the longest time to market and the highest fixed cost. In this image, let's say the most important thing is the y-axis. In the above part, we have a system with a high CPU power, a GPU, AI-specific hardware, support for many cameras, many peripherals, and so on. In the above part, we have instead, in the contrary, a system with a low CPU power, maybe no CPU, no AI capabilities, maybe no cameras to support, few peripherals to support, and so on. A smart module is a quite powerful module. So it comes with, as I already said, high CPU power, GPU, AI feature, and so on. So a smart module is an ideal when you need all these features. So processing power, cellular connectivity, all integrated, support for many peripherals, and so on. So far, I analyzed the various design approaches, the chip-down, the module, the smart module approach. I had underlined the main advantages of using the smart module, and also some criteria to choose the right design. Here I want to talk more broadly about the smart module and to discuss the typical use cases. In this slide, the use cases are divided by chipset performance in the y-axis. So starting in the bottom from the entry tier chipset to high tier or premium chipset. In the entry tier level, we have let me use the laser. In the bottom part, we have the payment vertical, like vending machine, POS system. I have to say that these are the most important vertical in the smart module field. Just to give you some number, the whole smart module market is maybe 80, more or less 80 or even more % of the smart module market is in this vertical. But also there are other use cases that are quite important. For example, the telematics field, the mission critical push-to-talk, high-end telematics, and so on. But also tablet, PDA, industrial tablet, industrial PDA, and so on. In the middle, even better in the high tier chipset performance, smart module are able of run AI algorithm that are also quite complex or quite demanding. For example, in the telematic field, leveraging smart module, you can develop application like driver monitor system, advanced driver assistance system, and so on. Finally, in the high to premium level, you can have a use case like drones, like robotics, especially I have to say that in this field, AI features are becoming always more important. Now I want to talk a bit about the Android operating system. But why I want to speak only about Android? Because Linux is quite popular in the IoT field, but in the contrary, Android is not quite so famous in the IoT field. Of course, it's quite popular in the smartphone field, from which they are derived, from which smart modules are derived. So, first off, the portability is quite important in Android. This is because Android offers a high level, a higher abstraction level with respect to other approaches. Also, with respect to Linux, that is also a high-level operating system. So, developing a new software application in Android is easier and quicker with respect to any other approach. Also, it's easier to switch your device, to upgrade your device to a newer version, because, as I already said, the Android applications you have developed will work with little to no change in a new smart module, in a new version. Also, there is another, I would say, quite important aspect to consider. That is possible to exploit, to leverage almost any application of the Android ecosystem. So you can, for example, leverage many of the open source projects that exist in the Android ecosystem, and this could accelerate your development time quite a lot. Another important point is that Android is, speaking about security, is a best in class. Because first of all, consider that it's the main operating system used in smartphone. So it's used in more than 3 billion active devices in the whole world. It's considered one of the most secure operating systems in the world. behind Android, there is Google, and Google has been putting a considerable effort in securing Android. Finally, I want to underline an important aspect. Android is a long-term investment. Why? Because of its, as I said, for its portability. With Android, it's easy to develop. Your application will run smoothly in almost all smart modules. So in the future, it will be easier for you to upgrade your device. And also, you focus more on building software application rather than on hardware or low-level details. To give you more details of, let's say, how easy it is to develop a new software application in leveraging a smart module rather than in a IoT classic solution, I want to show you some more details. For example, in a smart module, you don't have to deal with a T command. And you deal with Android APIs that are high-level APIs that you can leverage to build your application. So it's easier. From an application point of view, you leverage the application that is inside the smart module. You don't have to deal with an external CPU. If you need the support for a multi-application, in a smart module, it's seamless because it's already supported by the operating system. This is not true typically in a simple module approach. Also, from a language point of view, we use Java or Kotlin that are high-level programming language, and it's much easier to develop application leveraging this programming language. Also, you develop Android application leveraging standard tools, open source tools from the consumer world, from the Android consumer world, rather than using platforms that are specific for the module, for the vendor, or maybe are proprietary of the chipset vendor or the module vendor. Now it's time to see the smart module that Telit Cinterion has in production, the SC250B4. Please note that Telit Cinterion, we have other smart modules that are under development that are not shown here in this webinar. If you are interested in more detail in the other smart module we are developing, please get in touch with us. So the SC250B4 is the current smart module in production offered by Telit Cinterion. It comes in 3 variants, one for the two cellular variant and one Wi-Fi only variant. One variant is for the North American market, the other one for the EU, China, and other regions. It leverages a Qualcomm QCM 2290 chipset that comes with 4 core CPUs at 2 GHz, so quite powerful. It has a GPU at more than 800 MHz. It comes with 16 GB of flash and 2 GB of RAM. In the Wi-Fi only variant, we have 32 GB of flash and 3 GB of RAM. It integrates Wi-Fi 5, a Bluetooth 5.0, and a GNSS positioning system. It is already, all the main regulatory industry certification have already been done, and also several MNO certifications. From an operating system point of view, it comes with Android Go 13, but we are upgrading it to support also Android 14. And also it supports Yocto Linux. These are the main characteristics. It is a LTE Cat4 modem. The SC250B4 comes with its development kit. The development kit, the evaluation board, is a complete peripheral-rich system that you can use to build your software application. It's quite easy to develop a new software application. And the developers can build application on the Android operating system as they do in smartphone. You can see here that, for example, a touch screen, when you switch the evaluation kit on, you basically have a smartphone. So you have you have Android inside, you use it exactly as you do a smartphone. You connect a USB cable and you run your software application that you have developed. Here you can see some more details. As I said, this is a touch screen. So here it's basically a smartphone. This is the module with the modem inside and the CPU and so on. You can see, for example, here a battery. There is also a battery charger, several buttons for switching it on and off, for the volume up and down, digital microphones, 3 cameras supported, USB-C connectors for all the antennas for modem, for cellular, GNSS, Wi-Fi. There is inside a speaker, some sensor like there is a vibrator and so on, light sensor and so on. As we can see here, if you switch the evaluation kit on, you have a smartphone. Yes, you can see in this screenshot. This is Android and is exactly as a smartphone. So it's really easy to develop an application in the evaluation kit. It's all for me. Thank you for attending this webinar. Have a good day.
Thanks so much, Fabrizio. Just real quick before we wrap up, audience, I am going to drop a poll on your screen here. If you'd like to have one of our experts contact you directly, please just respond here on the poll and we will be sure to connect you with someone. Fabrizio, really appreciate your time today. Great presentation. And thank you everybody who joined us. Have a good one.
Thank you, Amanda. Thank you, Amanda. Thank you all. Thank you for attending. Bye-bye.